Heyo, Miss Middleton here. Um, we are talking about orbital motion, and so I need you to get your notes and let's go ahead. So if this isn't your class, that's okay. Remember, it's the same setup for every class. This is Unit 2, Exosphere. You're going to click on Function and Formation of Other Celestial Bodies. This is our first part of it. And here is our Unit 2, Functions and Formations of Other Celestial Bodies notes. I'm going to make a copy. You should just open it up. Okay, so here's our notes. Sorry, I jumped from one side of the screen to the other, but initially, back in the day, if I'm looking at these notes right here, this version, we see that the geocentric universe is the first type of idea people had about how our solar system worked, and how the universe worked. And it makes sense, right? So when you're sitting on Earth, you don't feel it moving. These people didn't have the technology yet to figure out that, like, okay, we're not the center. So initially, they're like, hey, when I sit here on Earth, I don't feel the Earth moving. I do see the sun go by, and I see the moon go by, and I see the stars go by. So we have to be the center, right? And so that's how they came up with the geocentric universe. Geo meaning Earth, centric meaning centered. Geocentric, Earth centered. All right. And here you have the planets and the stars revolving around the Earth in a perfect circular orbit. So this is another thing of the times. Think back before Galileo, back before Copernicus. At that time, the church ruled the world pretty much. And so what we have here is the church saying, God is perfect. God made us. And so we are perfect. Everything about space is perfect. Everything's perfect. And again, this makes sense with that logic. So a result of apparent motion. So it appears that the sun goes by us. It appears that the stars go by us. So motion of other celestial objects from our view on Earth is showing us that, hey, it kind of looks like we're the center. And again, this makes sense. So if I'm going to your notes, I define geocentric as the planets and stars revolve around the Earth, Earth-centric, and we need to put everything in the correct place. So Earth is going to be this blue guy. I'm going to make the crosshatch right there so I know it's absolutely in the center. We have these circular orbits. Next up would be the moon, so this little guy hanging out here. Then Mercury. Bloop. Mercury, and you can just slap them on any Venus, on any of these orbits. And the sun. Bam. Save and close. Perfect. All right. We then have technology evolve. And we come up with a heliocentric system. So the sun is the center of our solar system. Helio, I always think about how hydrogen is making helium inside the sun. And so helio, sun-centric, or you could like know Greek mythology and stuff like that. But I don't feel like knowing that. So heliocentric, sun-centered, okay? Let's highlight that. So sun-centered, boom. Instead of it being the whole universe, it's just our solar system. And this came about because Galileo was messing around with his telescope that he created, and he was looking at the moon. And remember, up in the geocentric universe, everything's perfect. Planets, the moon. And when Galileo took his little telescope and looked at the moon, he was like, oh, there's craters and all. It's not flat and smooth or anything like that. And so that's the moment he's like, wait a minute, maybe everything isn't perfect as we think it's perfect. And then he looked at Jupiter and he was like, wait a minute, there's moons going around Jupiter. What? Jupiter has something going around it, which means it's not going around us, which means we're not the center. And so let's highlight this. Not everything revolved around the Earth. That's the big ticket there. go ahead and click on our drawing here. So now we're thinking the sun is in the middle. And I would make sure that the sun is kind of off to one side because that's accurate. Then you're going to grab Mercury, Venus, Earth. Slap them on there. So whenever your parents say, hey, not everything revolves around you, you aren't the center of the universe, they're actually right. Mark it down. And you can slap some knowledge in there and be like, you're right, mom and dad. We live in the heliocentric system. And they'd be like, what? And you'll be like, knowledge. Mic drop. Anyway, so when we're talking about how planets move, so that's what we know of our whole solar system right now. If we move on to how our Earth moves, there's two ways that the Earth moves and most planets move. All right, so there's rotation, which is to spin on an axis. There. Let me grab my Earth. Okay, so it spins on an axis, and what we mean by axis, if you can see this right here, and this right here is like a pole that goes through. It's an imaginary line. In real Earth, they make it an actual like pole going through, and it spins around that. So spinning around this axis. Okay, so it takes 23 hours, 56 minutes, and 4.1 seconds. So whenever your parents are like, oh, there's not enough time in a day, and you're like, you are right. Everyone says 24 hours, right? With 23 hours and 56 minutes. So we make up for that lost time. We add every day, we'll add up those extra minutes that we're missing. And in every 4 years, we just slap another day into our year calendar to catch ourselves back up. So weird, but it's how we do it. All right, this is going to cause half of the Earth to be exposed to sunlight while the other half is bathed in darkness, and that causes day and night. Boom. Highlight, boom. All right, so if I was going to show you, that's what it would look like. Okay. Where did my, there we go. Okay, so let's double click. We're going to draw it. I like to use my scribble tool, and I'm just going to try and make a nice little swoop here. Moving around like that, and then I'm going to go over here and where it says line end, I'm going to put an arrow, and then I'm going to make it fat because I like when I can really, really see it. Boom. I'm going to do it again up here. What? And up here. What? So we know it's spinning around this axis. All right. Save and close. Boom. All right. Revolution then is the time it takes one planet to orbit around the sun. Orbit around the sun. So pretty much how long does it take to take a lap around the sun? How long is a year? It's the path the planet follows due to gravity. That's the orbit. And it takes 365 days for us to take a lap or revolve. So revolution is talking about making a lap around the sun. And this causes seasons. I'm also going to type in, it's not just our revolution, it's our revolution plus our tilt. That's going to make seasons. Okay, so double click, get your scribble tool, and start at the planet, try and go along this. Ooh, not quite, but I'll end it like that. Make it fat because I like that fat, like that. Boom. Save. Not beautiful. Where did my drawing go? Oh, she down there. Okay. Can I make this a little smaller maybe? Okay, hold on. Save and close. Let's make you a little bit smaller. Does that work? Yeah, you're on there now. Cool, 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 cool. All right, that is our notes for today on orbital motion. We'll talk more about how these orbits look tomorrow. Bye.